All right, welcome to lesson 9.3. Here on the bell ringer, I've already made a couple of adjustments. Make sure what you're going to do on your own today is you're going to graph all 5 of these problems and try to match them up. I'm not the greatest artist, as you well know by this time, but here are your 5 shapes. Just kind of a general drawing. Graph all 5 of these. Notice this first problem was the r squared. Desmos won't handle it that way, so we've changed it to r equals square root of 9 cosine 2 theta. Graph 5 of those, see what you come up with. Pause your video and we'll get going in a second. All right, let's take a look now at lesson 9.3. What I'm going to do first off here, let me close off some of these files. We're going to go to your class period and go to classwork and open up 9.3. So we're opening up 9.3, and the fact that you're listening to me means you've taken care of number 1. Number 2 here, make sure you fill out your attendance link if you haven't already done that. You can either scan this QR code or click this link here, and then open up this lesson exam right here, number 3. In between number 3 and number 4, your homework are these 3 tools to help out today. I'm going to use pre-programmed graphs, specifically one in particular. And we will use the unit circle as well. If you want to open up one of those on your own computer, I'll just pull mine over. I have a little bit clearer picture that I'm going to pull over when the time comes. For calculators today, we will use number 28. So if you want to go ahead and open that up, that's what we're going to be using here today. All right. So today's lesson is we've been dealing with polar and rectangular. Today we're going to be learning about how to go back and forth, which honestly, I have taught you all of this. By image, it's what I was trying to walk through for quite a few class periods now, of like when we were putting together different vectors, like when we were doing this little chart here. It's the math that relates the x and the y to the r and the theta, and vice versa, the r and the theta back to the x and the y. That's what we're going over today. So the textbook at this final stage, here, this final stage of normal pre-calculus, the only 2 chapters left are 11 and 12. We covered 10 back before Christmas. The only 2 chapters left deal with AP Calculus and AP Statistics. So it's teasers. This is it for pre-cal. This is the last lesson here for us. They finally give us the relationship that we've been working with since chapter 8. And it's this, that you can view an x and a y as a triangle, or you could view it as a radius on a circle here. And you can convert from x and y using Pythagorean theorem to get to the r, or you can be given an r and a theta and find x and y using trigonometry if you look at it as a triangle. So that's what this is walking through here. So let me back up all the way to chapter 4. In chapter 4, we said that sine theta was y over h. Sine was y, and we said cosine was x, cos x with a silent h. Well, on this document, this picture, I want you to see that the radius is the same thing as the hypotenuse of this triangle. They're one and the same. So in chapter 4, we were dealing with triangles, and so we used the letter h. Well, if we viewed it in terms of lesson 4.3, which was unit circle, or where we are now in polar, dealing with circles, we would say, okay, I don't want an h. I want to deal with it as if it were a radius. And now what the textbook does is they change the look of the problem. They just do a little algebra. From chapter 4 to chapter 9, the textbook builds all this algebra of simply multiplying by r. It takes 5 chapters for them to finally multiply both sides by r. And now here in chapter 9, we find out that y is r sine, x is r cosine. So that is x and y as a rectangular coordinate. Here, this is rectangular. X and y is a rectangular equals r cosine r theta, which those would be polar values there. Okay, so that's the conversion. We have a slide later that'll show you how to get back. That would be x squared plus y squared equals your hypotenuse squared or a radius squared. And we would use inverse tangent for the y and the x to get to the theta. but we'll get that on another slide here in a moment. So anyways, let's start at the beginning. It says find the rectangular coordinates for point D, which is 2 comma pi over 3. And as a reminder, what that means is if you're given an angle here, we are in polar form. And so this means go to the second circle up at pi over 3, which would be this point right there. We label that as point D. And we want to find this in terms of x and y. So visually, we want to say if this was a y-axis, if this were a y-axis, I should say, and this were an x-axis, so x and y-axis, what point would that be in terms of x and y? That's what I'm trying to establish here. Where would this be? Where would this run into the x-axis? Where would this run into the y-axis? This point here. Where would it connect to the x? Where would it connect to the y? That's what I'm on the hunt to determine. Okay, so what did the equation just tell us on the previous page? It said this: if you need to find your x value, just take the radius and multiply it by the cosine of the angle. And if you need to find the y, take the radius and multiply it by the sine of the angle. So we could plug in our values, and I will use the calculator in a moment. I know I told you to open it up. So it'll be 2 times the cosine of pi over 3, and y equals 2 times the sine of pi over 3. Now, what I love about this here, the homework side of Alex, is Alex can make you give it an exact answer, not any decimals, but the exact value in terms of a square root. And I like that, because it requires you to go back and use the unit circle from lesson 4.3. So I'm going to just have this ready because I'm going to use this quite a few times today. I know a lot of these numbers might be small for you, but I'll try to show you the best I can where they come from. So pi over 3 is located right here. And by review, every point on the unit circle is listed as cosine theta, comma, sine theta. So if I have pi over 3 here, that means the cosine is 1/2 and the sine is square root of 3 over 2. So I'll substitute that. I put an y there. No one corrected me. That's a problem. There we go. That should be an x. Let's fix that. That's bad math. Okay, so x is going to equal 2 times. Well, we're saying we're going to substitute cosine of pi over 3 with 1/2. And the y here, I'm going to substitute sine of pi over 3 with square root of 3 over 2. And so when I simplify, I'm going to get my actual answers. I'm multiplying by a 2. 2 times 1 divided by 2. The 2's will simplify out, and so it looks like the x is going to equal 1. Over here, I'm multiplying by 2 times the square root of 3, and then I'm dividing by 2. The 2's will simplify out. We have y equals square root 3. And so my point as a rectangular coordinate would be 1 comma square root of 3. So this did give away that my x value was going to be 1, but we did not know the y would be the square root of 3. Square root of 3 is about 1.7. You can see it's in between circles 1 and 2 on the polar graph. Okay, so I told you to open up the calculator a second ago, specifically number 28. And so this point was given to us in polar. So I'm going to go to polar here, and I'm going to type in the 2 values. They were 2 and pi over 3. Now, for this math to work out, I had to add a little mode down here. This is set up for polar degrees. We're not in degrees. Not only do you need to switch this to radians, you need to come up here and switch this mode to radians. I think I should say that. I just kind of reprogrammed this today. Actually, on that one, it did not change. Oh, yeah, I think, did it change it? Yes, it did change your value. So you need to make sure you're in radians there, because that's what pi is. So when I changed to radians, there's the polar point, and it does give us that 1. And hey, there's that 1.7 I was talking about earlier. The square root of 3 is 1.73205080757, and it keeps on going. There it is for you. So we did that one correctly. Let's try again. B here. Find the rectangular coordinates for the point F, which is listed at -5, 45. So if you remember what that means, that -5 magnitude means don't go 5 circles towards 45 degrees, go away from it. So 45 degrees isn't on there. Let me add a little pole for 45 degrees. Here's 45 degrees there. And on this side, let's see here, it'd be in between 15 more, it'd be 225. So -5, 45 degrees. And let me add the circles. I don't have 5 circles, so I better count by 2s. 2, 4, 6, and 8. Okay, so we're going to be at the circle 5, or the magnitude 5, and I'm going to put it on this spot here. Now notice I did not go towards the 45 degrees. I went away from 45 degrees because I had a negative magnitude. So point F would be located here. And I also want to remind you that you don't have to list it with the negative magnitude. You could rewrite this point F and say, well, it's 5 circles towards 225. That's another way of writing that point. There was 4 ways we could write any one point. That's another way we could have written that point. Okay, so let's solve this mathematically. If our x was going to be r cosine theta and our y is going to be the r sine of theta, let's substitute our values in and see what we come up with. We'll have -5 times the cosine of 45 degrees, and we will have -5 times the sine of 45 degrees. Oops. Here's my unit circle. And so if I go and find 45 degrees is listed right there. The cosine, the x value is the cosine. The y value is the sine. But on this one in particular, it doesn't matter because when you substitute, they're the same values. So we'll have x equals -5 cosine, not cosine, sorry, I'm substituting. Cosine of 45 is square root of 2 over 2. And for the y value, it'll be -5 times square root of 2 over 2. The mathematics here, they don't appear to simplify at all. So I'll write this rectangular point as being the x -5 times the square root of 2 over 2. And the y value -5 square root of 2 over 2. And that will be my solution. Here's my x-axis, here's my y-axis. This means this point right there is left 5 times square root of 2 over 2 units, and down 5 square root of 2 over 2 units. That's where that value would be located. That's what we just determined. -5 square root of 2 over 2 and -5 square root of 2 over 2 in terms of the x and y axis. Would my calculator solve this one? Yes, it would. We just need to be careful on our units. So this is our mode. It's in degrees here. So I would come up and put a -5 and 45 degrees. This is in degrees now, and notice my outside's in radians. So let me change to degrees. That switches where the point's located. And I also need to change this one's mode also for our calculations, I believe. Here is our 2 values. Let's check and see if that is -5 square root of 2 divided by 2. Those do indeed end up being the correct answer. So we did that correctly there. Let's try this one more time, and this time I'm going to give you a negative angle. Now I want to remind you, a negative angle means that we're moving around the circle clockwise. So instead of traveling and saying, okay, this is 330 degrees, we'll take its coterminal angle. We'll say that's the same thing as moving -30 degrees, because it's the same distance but going downward. So we'd say that's like -30 degrees. This would be -60 degrees. I'm just kind of taking these values across here. Whoops, forgot the negative. This would be a negative 90 degrees. Right on this side. This comes after 90 is 120, so it'll be a negative 120 degrees. This angle would be like negative 150. Here's 180. It's the same thing as negative 180 because it's right there in the middle. Okay, now that was to there. If I keep going past 180 negatively, it's like going past this way. So 210 would come next, negative 210, I should say, negative 210 degrees. And then finally comes our negative 240 that we were looking for. So there's negative 240. We want to be on the fourth circle. 1, 2, 3, and 4 at negative 240 degrees, which places that point right there. That is point H. And I'll remind you at this stage, you could have rewritten this point, saying now that we know it's coterminal with 120, we could say H has a magnitude of 4 of 120 degrees. Now let's find the rectangular coordinates. The formula we learned just a moment ago is that you use r cosine theta, and we use y equals r sine of theta. I'll say x equals, not r, I'm sorry, 4 cosine of negative 240, which I'm going to actually use 4 cosine of a positive 120. And then the y would be 4 sine of negative 240, which you could use for the calculator. But for the unit circle, which I'm about to use, I'm going to use the value positive 120 degrees. It's coterminal value. Just realize I put parentheses in a different spot there. There you go. Make it look consistent. So here's my unit circle. I find 120 degrees right there. There's my sine value. That's my cosine value. So x would equal 4 times negative 1/2. And the y would equal 4 times square root of 3 over 2. When I simplify these values out, the x, 4 times positive 1/2 would be 2. So 4 times negative 1/2 will be a negative 2. And then here, 4 times the square root of 3 divided by 2 will just become, it's kind of like 4 divided by 2 is 2. So it'll be 2 times the square root of 3. That will be my solution. So visually, what does that mean? That means that point H that we already have plotted, if we compared it to an x and y axis here, the x value would be left 2 units, so it'd be negative 2. The y value would be up 2 square roots of 3 units, which I mentioned earlier, square root of 3 is like 1.73. If you doubled that, it'd be basically 3.46, something like that. So you can see it's in between circle 3 and circle 4. That would be the point. Again, using my calculator, we're in degrees, so make sure both this mode is in degree and this over here is in degree. You need to have both of them in line just to be 100% sure you'll get the right answer. 4 at negative 240 degrees. There's that polar point right there. The value would be negative 2 and that 3.46 I was mentioning. All right, with all that, we come to our first DOL. Whoops. Here it is, DOL number 1. And while I open this up for you, what I want to make sure you have to work with, let me move that over there so you can try to plot if you want. And I'm also going to give you a unit circle to look at. All right. Now, before I move on, one thing you could kind of have done, a little bit of a cheat here, is you could have viewed this graph where the point was plotted and then just kind of see off of the positives and negatives. Whenever you plot the point -8, 300, whether x would be positive, negative, if you were not even going to use the unit circle or calculator, you kind of go by somewhat that way. And then once you know what quadrant it's in, and you determine positives and negatives, whether you move from the center further on the x-axis or less than on the x-axis compared to the y, on which value would be bigger or smaller. But there it is. Either way, we got great data there, 94%. Let's now take a look at going the other direction. So as we started this lesson, I mentioned, hey, this came from basically lesson 4.3 that we're combining the stuff together. It'll work just fine. Okay, got my circle there. Oh, I wanted to get a dotted circle, sorry. That's why I went over here. I didn't click anything. All right. So I showed you on our previous slide how they relate everything together, x, y, and the radius there. You could view it as a triangle with the angle in standard position, or you could view it as a circle with this being now a radius. What that means is that r would equal the square root of x squared plus y squared. You might be saying, why is that the case? Well, it's the Pythagorean theorem. It's really what that is. If you squared both of these, we would have that r squared equals x squared plus y squared. And again, since this is the same thing as a hypotenuse, we could also say that x squared plus y squared equals the hypotenuse squared, which was our Pythagorean theorem. So you can see how those all relate together. I'm going to take off the square there. You can see how all of those relate together. Now, what about the angle? If you remember in your calculator, the calculator inverse tangent does not give you any values over here. Tangent inverse of y over x will not give you a value over here. So what do you do if your angle needs to be on the left side of the graph? Well, you either add 180 degrees or pi, depending on if you're in radians or degrees. So that's how you make up for if you can't get it, if you have an angle that's supposed to be in the second or third quadrant. And that's what this is telling you over here. So now let's take a look at a couple examples of going from rectangular to polar. So we're going to plot a point and find it twice in polar coordinates. So the point E is 2 to the right and 4 units down, right there. That's point E. What we want to determine is what's our radius and our theta for that point E right there. So we want to solve for theta and the radius. That's what we're trying to find. This is given to us in a rectangular form, x comma y. So the formula we just wrote down is that if you need your r value, you can use the Pythagorean theorem. And if you need your theta, and well, let me put here since x is positive, since x is greater than 0, if you want this angle, all you have to do is the inverse tangent. You don't have to add 180 / pi. So plugging in our values, r will equal the square root, x is 2, and y is -4. Which 2 squared is 4. -4 times -4. What is -4 times -4? Positive 16. When I add 4 plus 16, we get 20. I'm going to try to simplify this square root. I like to use the technique upside down division. So I'm going to take 20 and I'll divide it by prime numbers. 2 is the smallest prime number. So prime numbers, anything can be, only 1 in itself can multiply into it. So 2 is going to be the smallest prime number I use here. 2 goes into 20 how many times? 10. And you keep doing this till you're left with only prime numbers. 2 divides into 10 how many times? 5. And 5 is prime. So I have a pair of 2's. And since I'm doing a square root, I circle up pairs. So 2 comes outside the square root. 5 is a single, it goes back underneath the square root. If I had multiple pairs, I would multiply them on the outside. If I had multiple singles, I would multiply them inside the square root. But either way, I'm left with 2 square roots of 5. That's my radius. Now for the inverse tangent, we will say theta would equal tangent inverse of -4 divided by 2. And the truth is, for most tangent values, we don't have these memorized. We're going to have to use a calculator. You probably don't need to reduce this. You can just go straight to the calculator. But I will just one time here. -4 divided by 2 would be -2. So I'm looking for the inverse tangent of -2. And I'll have to get that from the calculator. Instead of just typing it in like that, what I'm going to do is come over to this calculator. I'll refresh, because I want polar to go away. We're now dealing with rectangular, and our point was 2 to the right. It was 2 to the right, and it was 4 units down. So there's my rectangular point there. And what this graph tells us is that if you look over here, I'm in by default degree mode. It tells us that the R is 4.47, which let's check that if that's 2 square roots of 5. 2 square root of 5. It is, that's accurate. And then it does the inverse tangent that I was mentioning. And it comes up with -63.43 degrees, roughly. So this theta is roughly -63.43 degrees. Now, what if you wanted it in radians? What you'd have to do is, to be safe, not that it will always matter on my little slider here, but there are times when it will matter. If you're on the left side of the graph, if x is less than 0, then this one will matter. But what will always matter is on this graph settings, you need to change that to degrees. I mean, from degrees to radians. When I do that, I get, we'll call that -1.11, -1.11 radians. And as a reminder, what a radian is a radian is the angle at which the arc, like kind of like the portion of the circumference, the arc, is the same as the radius. So this means this distance from here down is a little bit longer than the radius itself. That's what that means. Okay, so how would you write your answer? You'd write it as r comma theta. So in degrees, it would be 2 square roots of 5 comma -63.43 degrees. Or we could say this is 2 square root of 5 at -1.11 radians. Like that. Now the problem actually says write 2 pairs. So you see how it says 2 pairs? So what I'll do is I'll write the coterminal value. What if we wanted a positive theta here? I'll do this, we'll call it theta 2. If I wanted that, I would need to add a whole circle. So if I added 360, I would still have 2 square roots of 5 for my radius, but I could look at this as a positive angle if I added 360 to that. So let me take my -63.43 and add 360. I get 296.57. 296.57 degrees. That's another way of describing that point. And if I wanted it in radians, I would need to add 2 pi. So let me put that note here. That was theta plus 360. And now I'm about to do here theta plus 2 pi to get this one. And so come over here and we'll change this to a negative, let me just write it again, -1.11 plus 2 pi is 5.17. Oh, I forgot the word radian, sorry. Radians. Since it doesn't have a pi, I better include radians so we know what we're doing there. All right, so there it was. I listed 2 different pairs of polar points, and I did it not only in degrees, I did it in radians as well. Remember, there's 4 different ways you could write this point. I just chose to go one full circle. All right, let's try this all over again. So this time it says find two pairs of polar coordinates for the point -2, -4. So I go left 2, down 4, and here's my point G. Did I label the last point? Yeah, I did. And what we want to know is what's the R and the theta for this point here. The R and the theta for that point there. That's what we're looking for. Okay, so our formula, if you remember, is that R is going to equal the square root of x squared plus y squared. And since this time x is negative, since x is less than 0, I'm going to use the formula that theta equals the inverse tangent of y over x, and it's plus 180 if you're in degrees, or if you're in radians, it'd be the same thing but plus pi. Whoops. Y over x plus pi if you're in radians. So these are going to be our two formulas that we're using. 3 if you want to count those as separate. So I go to plug in my values. We have an x and a y that we know. So R would equal the square root of -2 squared plus -4 squared. Okay, -2 times -2? 4. And -4 times -4? 16. 4 plus 16? 20. We already reduced that square root a little bit ago. You might remember that was 2 square roots of 5. Because that is the square root of 4 times the square root of 5, and square root of 4 is 2. So yep, that's it. So there's our radius. Now let's take a look at what we're going to get over here. So what you could type in the calculator is the inverse tangent of -4 divided by -2, which by the way is +2 if you wanted to put a +2. You want to type in just as I wrote it. And then you'll either add 180 or you'll add your pi depending on what mode you're in. So let's see what we get for our R and our theta here. I'm going to go to the calculator. I'll refresh this. We will work in, let's do degrees first, because when I refresh it, that's what the mode it's standard in. And so we'll go rectangular. It was 2 to the left and 4 down. There was the point. It said, it gave us that same value that we found earlier, 2 square roots of 5. The angle it lists is 243.43. 243.43. degrees. Or we could, if we want to switch this to radians. Now check this out. I have to switch this one over to get it to radians here. And I have to switch both of them over. I switch both to radians, and now I get this value. We'll call this 4.25 or 4.25 radians. So my answer here in degrees would be 2 square root of 5, comma, where'd it go? 243.43 in degrees, or 2 square roots of 5, comma, 4.25 radians. Again, if you don't have the pi symbol, you need to fill in the word radians so you know what you're talking about. Otherwise, it's really confusing, which I'll show you in the next problem. Now, this says write 2 pairs, and we don't have 2 pairs yet. So how could we find a second pair here? What I will do this time is I'm going to list it as the negative hypotenuse. I'm going to remind you how we could do it this way as well. Kind of like using a negative magnitude or a negative hypotenuse, negative radius. what I'm going to do is say this is equal to, and if you're going to use a negative radius here, what I'm going to have to do for the first quadrant is subtract 180 degrees or subtract 1 pi. So that's what I'm going to do here is I'm going to take my angle and I'm going to subtract, subtract 180. So I'm showing you multiple ways of going about this. In the last problem, I added 360. We could have subtracted 360 here. I'm going to subtract 180, which means I need my magnitude to go negative. So magnitude goes negative. Your magnitude is going to go negative when you add the 180 or subtract 180 here, I should say. So that goes negative, and now I subtract 180. Let's see what that value is. Come over here. We had 243.43 minus 180. We end up with 63.43. There's a second pair. Or if we want to do this in radians, we take that number 4.25 that we had, 4.25, and I subtract 1 pi. So I get 1.1. 1.11 radians. Close my parenthesis there. Whoops. There we go. Got it. Okay, and so again, all that happened simply because you can add 2 pi, you can subtract 2 pi, you can do all that you wanted to do. But if you do 1 pi or 180, you need to make the magnitude switch from positive to negative. And that's what I did here this time. Okay, so I've shown you multiple ways of going about this. I'm going to let you try this one. Luckily for you, your answer choices here, that if you only view the positive answer choices, if you only view this answer choice versus this answer choice versus this answer choice versus this answer choice, you can actually just get your answer straight from technology, but I'll let you do this problem whichever way you want. But those are the 4 answer choices. If I were you, I would compare to see which one of those is accurate for this problem. This is DOL number 2. And also, these do not have degree symbols. That means these answers are in radians. That's why I was kind of mentioning a second ago. This is confusing because it doesn't say radians. This should have written on it that these are in radians. All right. Now I want you to draw your attention now to the alternate answer choices. Since the magnitude is negative on all of these, what that means is they subtracted 1 pi. Or added 1 pi, depending on what you originally got. So for example, if this is your original answer, they added 1 pi, they added 3.14 to get to this answer. If, however, this was your original answer, they subtracted 1.4 to get this with the negative magnitude. Just the same here, but adding 3.14 to 0.88 or subtracting 3.14 from 4.02. That's how those answers were generated. Now let's take a look at example 3. We're basically going to work through the same thing we've been doing one more time here. So I'm going to add an X and Y axis just so you can see both polar form and rectangular form on the same visual aid here. Okay, it says suppose the robot's arm is facing due east. Okay, so north, east, it's facing this way. Here's the east. So northeast, this would be south and west, by the way. Let me put the north on there, north. Okay, and so the robot's facing this way, and it detects an object at 3,280. 1, 2, 3, 3 at 280, which we don't have a good spot for that, so I'll just do the best I can. I'm going to assume that's about 3 right there. And it doesn't give it a name, since they call it an object, I'll call it O. O for object. Okay, so what are the rectangular coordinates for that that the robot will need to calculate for that point? Okay, so in terms of x and y, we can see it's a positive x and a negative y, but let's come up with it. Well, as a reminder, the formula we know is that x is going to be equal to r cosine of theta, and y is going to equal r sine of theta. 280 is not on the unit circle, so I can't use that, but I will still fill in the values. It would be 3. This is polar, so that's r comma theta there. So it would be 3 cosine of 280, and y would equal 3 sine of 280. We can go to our calculators and figure this out. I'm just going to refresh my Desmos here. This is polar, so it's 3, 280. This one is in degree mode, so I need to make sure my mode here is in degrees. I'm in degrees. My calculator over here is in degrees. Perfect. So there's that point. It turns out that in terms of x and y would be, for the x, about roughly 0.52. And for the y, roughly negative 2.95. So the rectangular coordinates, x comma y, I'm going to put here 0.52, negative 2.95. There's our answer there. And let's take a look at part B now. It says if a previously detected object has rectangular coordinates of 4, 9, let's say 4 to the right on the x-axis, 4 to the right, 9 up right here. If that's our point, I'll call this just point T. What are the distance and angle measures of the object to the front of the robot? So basically what we're looking for this time is the radius and the theta. We're looking for r and theta here. So the formula that we had for this is that r can equal the square root, not can, does. R does equal the square root of x squared plus y squared. And since x is greater than 0, the theta will just equal the inverse tangent of y over x. So solving by hand, r would equal the square root of 4 squared plus 9 squared. And theta will equal the tangent of negative 9, or not negative, I'm sorry, positive 9 divided by positive 4. I'll reduce this side by hand, or the r value. 4 times 4 is 16. What about 9 times 9? 81. Does anybody know what 16 plus 81 is? 97. Very good. I think that's a prime number. I could be mistaken. So later, if you see the notes, it's different because I've realized, oh, that wasn't prime. It can be reduced. I don't think that square root can be reduced. This I'm going to get from the calculator. So let's go see here. I'm going to refresh this calculator. This time my value is rectangular. So I'm going to go rectangular. 4, 9. Here's the answer in degrees. Theta is approximately 66.04 degrees. Or in radians, switch both modes here. In terms of radians, it'd be 1.15. Square root of 97, which we know that number is right. I didn't check it because square root of 100 is 10. So it should be just under 10. This is the square root of 97. 66.04 degrees, or square root 97 comma 1.15 radians. That would be your solution this time. Okay, so you saw me do this through one more time. I'm gonna let you try. Here's your DOL number 3. All right, the last 2 examples here. What we're going to do is now focus on equations. And so the best technique, I think, for converting a rectangular equation to polar or vice versa is to simply look at all the equations together. And so I'm going to write this out here. We have x equals r cosine of theta. That's equation 1. Equation 2 I'm going to refer to as y equals r sine theta. Equation 3 could be written 2 ways. You could use that r is the square root of x squared plus y squared. But oftentimes when you're dealing with equations, you're actually going to be solving it in terms of r squared equals x squared plus y squared, because rarely will you have an equation with a square root of x squared plus y squared like that. So typically you'll be solving an equation using the third in this form. And then finally, I'll kind of do the same thing. What we've seen today is that theta is the inverse tangent of y over x. That's the inverse. Rarely do we actually see the inverse, but we might see it as a tangent. So I'll say tangent theta equals y over x. I'll write it in that format. So I'm going to still call it formula 1, 2, 3, and 4. And now let me copy, all this. As for the rest of the examples today, I'm just going to copy that and paste it each time. All right, so let's try to solve this equation. It says identify the graph here. Well, I can tell you, if you remember, that when you have both x squared and y squared, the function's either going to be a circle, an ellipse, or a hyperbola. And from the formula chart, let me go ahead and just open up the formula chart. We learned this on chapter 7. If this loads, thank you. Okay. A circle is when your x is squared, your y is squared, they're adding, and they equal some radius squared. That means if you divided by it, the denominator would be the same number. What was different with an ellipse is that the denominators would be different, so it would equal 1. On this problem, we have a circle because I do have an x squared and a y squared adding, and it equals 1 number. So even if you divide it across, the denominators would be the same. So it's not an ellipse, it's a circle. So that's what this graph is going to be here. So I'll go ahead and write it because it says identify the graph. Well, we're done. It's a circle. Secondly, it says write the equation in polar form. Support your answer by graphing. And so I already had the graph over here. That's why I covered it up. But let me show you the algebra here. So I'm going to copy down this equation exactly as it was given, which is x plus 2 squared plus y squared equals 4. And the way I go about doing this is I'm going to ask you, what pieces do you see that's unique? And I'm going to start with just doing one piece at a time that's unique. And later we'll start mixing and doing multiple steps at once. But what I mean is the first equation, what's unique is that it has a cosine, specifically r cosine, but it's a cosine. That's what's unique on equation 1. On equation 2, what's unique is it has a r sine. The sine is specifically. The third, what's unique is that you have x squared and y squared. That's what's unique. So again, what do I mean by unique? It's like these have r's, but they don't have x squareds and y squareds over here. This has x and y, but they're not squared, if that makes sense. So you're looking at the things that are unique. Over here, what's unique is that it's the theta by itself, or it's y divided by x. Those are the unique things that you were looking at. And so when I look at my problem, which category does it fall into for uniqueness? Category 1 with r cosine, 2 with r sine, 3 with the squareds, or 4 with a theta by itself? The squareds. So I'm going to be looking at this formula. Usually in the equations, you'll use this one. And so that's the formula I'm going to try to get it to. Before I can write in that form, I need to FOIL out, FOIL here, what is x plus 2 times squared? Basically, x plus 2 times x plus 2. Let's figure out what that is. If I want to simplify that, what is x times x? X squared. X times 2. 2x. 2 times x. 2x. And 2 times 2. 4. What I'm going to first do is rewrite this. And we'll say this is x squared plus 2x plus 2x is 4x plus 4 plus y squared equals 4. Now what I'm going to do is I'm going to combine, well, I've kind of combined some terms already, that 2x plus 2x is 4x, but I'll subtract the 4's across. And I'm also going to, I'll move the 4x over here. I'm going to notice I have an x squared plus a y squared. Now, what is x squared plus y squared equal to? X squared plus y squared. According to the third formula, x squared plus y squared could be substituted for, what is x squared plus y squared equal to? R squared. So what I'm going to do is substitute that, r squared. Now, I'm not done yet. And the reason I'm not done is because I still have x and y's, and I'm trying to get to polar form. Polar does not have x and y's, it has r's and thetas. So now I look at this and I say, okay, what does this have that's unique across the equations? So specifically, this has an x right here. Which formula do you think we should use if it has an x? Formula 1, 2, 3, or 4? But yeah, the first one, because it's just an x. So this time, what we're going to say is unique is the x. Not that it's perfectly unique. I know this has an x, but it's not squared. So I'm now going to look at this equation. And so we'll substitute that in. And so I'll have r squared plus 4 times, or I'm going to take out the x and replace it with r cosine. Now, because you haven't seen polar equations other than one day last class, you don't know this, but polar equations we usually write as r equals. So what I'm going to do here is just kind of get it in normal form by subtracting 4r cosine theta. Subtract 4r cosine theta, like that. And so my formula is almost in the right form. It's r squared equals negative 4r cosine. What I can do to simplify the problem is, you see how both sides of the equation have an r that's multiplying? This is r times r. This is negative 4 times r times cosine. What I could do here is just divide both sides by one of those r's. And now I got my equation in polar form. It's r equals negative 4 cosine theta. So if you remember from last class, this is a circle that if it's negative cos, will it go up, down, left, or right? It's a negative cosine. Left, because x is horizontal, negative means left. So it's a circle that travels 4 units to the left, 4 circles left. 1, 2, 3, 4. It's 4 to the left. All right, let's see that again, because that was a little different than what we've done before. No, that's not what I wanted to do. There you go. So now I'm going to look at the equation 2xy equals 4. This one, we can actually do a little algebra. I don't understand why they wrote it this way. You have a 2 multiplying and a 4 on the other side. How do you get rid of a 2 that's multiplying? It's the opposite operation. Divide. Okay, so we don't know yet, do I need to isolate the x or y, but I can simplify the equation by just saying x times y equals 2. Okay, now as you look at the equations, again, some of these are going to be a little tricky, I'm not going to lie. But I have x and a y that are multiplying. So what formula should we use? That x and y that are multiplying. Formula 1, 2, 3, or 4. If x and y are multiplying. Do you happen to see an x and y multiplying anywhere? No. So why this is tricky is you have to use these two together. We're going to use formula 1 and formula 2 on this one. So the x itself is r cosine. I'm going to kind of do it like this. X is r cosine. And y is r sine. So when I go to simplify these, I have r times r, which is r squared, cosine theta, sine theta. We'll try to isolate the r. So right now, r is multiplying times cosine and sine. What's the opposite of multiplication? Opposite operation of multiplication? Divisions. So what we will do here now is we will divide by cosine sine, which we don't see that very often. Division by cosine sine. So we have r squared equals, and now here, little chapter 5 identities. I'm going to go back to my formula chart. I'm dividing by cosine and I'm dividing by sine. If you look over here on the chapter 5 identities, when you divide by cosine, where is that? Here it is. When you're dividing by cosine, that's the same thing as multiplying by secant. Dividing by cosine is the same thing as multiplying by secant. And just the same with sine, when dividing by sine right here is the same thing as multiplying by cosecant. So these are identities. So we could say that this is the same thing as 2. Instead of dividing by cosine, we could multiply it by secant. And instead of dividing by sine, we could multiply it by cosecant. That's going to be my equation there. You might be going, so what the heck type of graph is that? Answer is it's a hyperbola. That is a hyperbola. We wouldn't have known it by equation because that looks quite a bit different, but that's a hyperbola. The reason is why hyperbola is it looks like the rational function that if you took your xy equals 2 and you divide by x, we learned this in the first semester to be rational. And it would have a vertical asymptote or an infinite discontinuity and a horizontal asymptote with limits going to infinity, or excuse me, to 0 as the x approaches infinity and negative infinity. So that we learned as a rational function with those asymptotes. Just to tie that in, that is chapter 2 right there. That was way back. So that's kind of the why it's a hyperbola. It's a rational function where these two pieces reflect back and forth. All right, with this, I'm going to give you this DOL. You're lucky. Your multiple choice has the shape with them, which means if you just graph this, you can get your solutions. But if you don't want to graph, if you want to go get through the nitty gritty, here's your equations for you to help you solve this problem. All right, now let's take a look at example 5. So now we're going to go polar equations to rectangular. I am still going to be using these equations here. These are the ones I'm going to be looking at. So the first problem says you have theta equals pi over 4. Okay, and I kind of go off the same thing I was asking last problem or last example set. Which formula would this deal with the most? Which one has the unique properties of theta equals pi over 4 that we'll need to solve that? Formula 1, 2, 3, or 4? 4. That's the one that has theta by itself. You could use this formula. It'll be easier if you think of it this way though. The second, that if I just take the tangent of both sides, if I just say, okay, tangent theta equals tangent of pi over 4, you can do that. You can just say, I'm going to take the tangent of both sides. This will be easiest to solve. Because from here, I can say, well, tangent of pi over 4 in the calculator, I'm just going to tell you it's 1. I won't just tell you, I'll show you. Tangent of pi divided by 4. Let me make sure. Whoa, I need to put that in parentheses, it looks like. Pi divided by 4 is 1. You need to make sure you're in radians for that to work out right, but it is 1. So that's going to be 1. And over here, tangent theta is y over x. So now that I'm in rectangular, most rectangular functions, if it's not squares, dealing with squares, where x and y are both squared, what you will do is you will get the y to be by itself. So right now the y is not isolated, it's being divided by x, so I would multiply both sides by x here. And we get that y equals 1x or y equals x. This is an equation of a line. This must be a line. Here it is, y equals x. A line with a slope of 1 goes up 1 over 1. One of the things, in case you didn't catch that tangent theta right here, I did a substitution where I said, okay, tangent theta is here, that's y over x. And that's where the y over x came from. All right, I think I got like 3 or 4 on example 5 to show you, just to make sure you have plenty of examples to compare this to for your homework. So now we're going to look at r equals 5. Now, this is where people start getting troubled, I think, more so when dealing with polar, because r's are shared in 3 of the 4 equations. But if you're dealing with an r that's pretty simple, you're going to typically do one of 2 tricks. You're either going to square both sides to get this formula. Actually, this is an r by itself. When I have it written, I didn't write it this way last class. This is going to be easier. Now that I have r by itself, I'm just going to use that formula right there. You see what I'm doing? That's what I'm going to do. Make this easier. I'll use this formula right there. I made a mistake last class not writing it both forms. Okay, so that right there is going to get substituted. X squared plus y squared equals 5. Okay, if you looked on the formula chart at our shapes, where did the formula chart go? There it is. I'm going to the different shapes and equations. Here, the chapter 7. You can see that none of them have these square roots with them. So I want to ask a question. How do I get rid of a square root? What's the opposite operation of a square root? A square. So what I'm going to do first here is square both sides. And when I do that, we have x squared plus y squared equals 5 squared, which is 25. That's the equation of a circle. This is a circle with a radius of 5. See part C. Again, we're going to have the same values, or the same equations rather. We look at the equation r equals 2 sine theta. Okay, but this time I still need to call out that what I was about to say about the tricks is I could substitute this r right away. But I don't want to do that because on this side, you see how I have the unique sign? And I said, notice sign up here is very unique as r sign. I want to use this formula. So here's a trick that you frequently have to do when converting from polar to rectangular is frequently you will either, if it's got a denominator, multiply the denominator, or if it doesn't have any denominator at all, multiply both sides by r. This is a very common trick. What I'm going to do is multiply both sides by r. So what that does is it gives me an r squared on the left side, but on the right, if I reordered this, I could say this is 2 times r sine theta. So now I'll do 2 substitutions at once. R squared, we have written here, r squared is x squared plus y squared. And r sine is y. When we're dealing with multiple squares, we get our variables together. So I'm going to subtract 2y across. So I'll have x squared plus y squared minus 2y equals 0. I'll leave a gap here. This is going to be, if you remember our chapter 7 coming back to us now, we need to complete the square here to get the equation in good form. Complete the square. It was a 4-step process, if you remember. Step 1 was you factor the a term. So here I'm going to put this in parentheses. My a is 1, so I factored. I don't have my a equals 1 here, so I don't have to do much with that. Step 2, though, I'm going to divide my b by 2. B divided by 2. So I'll take my b here, -2, and divide that by 2. So -2 divided by 2 is -1. Step 3, we square that value. B divided by 2, we square that. Which gives me a +1. And anything I add on the left, I've also got to add that on the right. Finally, step 4 was to simplify. You know what? I'm not going to write it right there. I'm running out of space. I'll write it over here. Simplify. That was our 4th step. So I'm going to rewrite this as x squared. If you remember the shortcut here, the reason you complete the square is this trinomial. What are factors of 1 that add to -2? It is -1 and -1. This trinomial will be factored as y minus 1 times y minus 1, or you can say y minus 1 squared. And that would equal 1. Again, this is the equation of a circle. The radius would be 1. It would be shifted up 1 because inside lies. So there's a radius circle with a radius of 1. Notice if I put the axis here. This circle has a radius of 1. It's shifted up 1 unit. Up 1 unit with a radius of 1. And this would be my answer right there. All right, last one. Well, it's not going to let me drag that over, so I'll have to just do it like that. Okay, so I'm looking at this equation. Let me pull it down. R equals 7 over 4 sine theta plus cosine theta. All right, like I was saying in the last problem, if you have polar and you're dividing, typically the very first step you're going to do is try to get rid of the division. So what is the opposite operation of division? Multiplication. So I'm going to multiply both sides by 4 sine theta plus cosine theta. I'm going to do that first. 4 sine theta plus cosine theta. So again, the tricks for polar are if it has a denominator, multiply by that denominator. If it does not have a denominator, but you have a sine or cosine, something like that by itself, multiply both sides by r. Those are tricks that happen very frequently. I'll distribute this out. So I'll have 4 sine theta times r, which I'm going to reorder and say that's 4r sine theta. And then I also have, I'm going to reorder this, r cosine equal to 7. Well, we know our sine is y. So I have 4y there. And our cosine is x. This is the equation of a line. That right there is a standard form of a line. If you wanted to get it in y equals form, you could subtract x from both sides. Say it's 4y equals negative x plus 7, and then divide by 4. You do it this way, but this is either way linear. Negative x plus 7 all divided by 4. You could write your answer this way as well, but that is a line. That's a line here. And here's the picture. Now here's one for you to try. Again, if you prefer, you can graph and go off the shape that you see to determine which graph is the correct, or which answer choice is correct. All right, now we're going to look at we're going to review back while we were on chapter 7. For so much of this lesson, let's look at 7.5 since we didn't see any of that. Let's say we're supposed to find the parametric equations for a curve with this parameter and this equation. How would we do so? Well, one of the things we can do is whenever you have two equations and you're trying to solve with parametric or parameters, is you solve for what is shared. Typically, I would say solve for the shared variable, but I see this is 3x, this is 3x. I'm going to solve for 3x. It'll make the problem easier. So I'll add 1. And so t plus 1, let me make that t different so you can tell it's not a plus. T plus 1 will equal 3x. Now that doesn't help us for the answer choices. So for a second here, I will say, all right, if I divide both sides by 3, t plus 1 over 3 would equal x. This will help us that we can eliminate answer choice C and D. But what I'm actually going to substitute is this 3x right here with this 3x right there. That means my y equation will be y equals, in parentheses, t plus 1 plus this one. Truthfully, when you substitute, you need to use an extra parentheses, so I should have one there, like that. And then this whole quantity squared. So t plus 1 is going to become t plus 2. Y equals t plus 2 squared. So it looks like I need to FOIL this out. Either way, I know it's not going to be that. So it looks like the answer is going to be B. And from here, if you did your algebra, just distribute all the way t times t, t times 2, 2 times 2, t, and 2 times 2. You would end up getting this when you combine your like terms. All right, and let's try the second one. What are the parametric equations for the curve given by, okay, it looks like the same type of problem. We're just reloading. What's shared is the x. This time, however, I do need to go ahead and solve all the way for x, because that's not a 2x over there. So I'd have t minus 8 equals 2x. Divide both sides by 2. And you can distribute that division. So I'll actually write it. If I distributed the division, it would be t divided by 2 minus 8 divided by 2, which is 4. So division is the opposite of multiplication. So you would still distribute it. They work hand in hand in that regard. They follow the same rules. So I'm looking for, that would be the same. B is out. C is out. It's either going to be A or D. Now I substitute this in over here for x. So we will have y equals, instead of that x, let's replace x with t over 2 minus 4. When I combine my like terms, we get y equals t over 2. Minus 4 minus 3 is minus 7. Now I need to square that. And when I look at my answer choices, I can't just directly get a good answer yet. I need to actually go ahead and FOIL this out. So let's write it out. T over 2 minus 7 times t over 2 minus 7. We need to distribute or FOIL, if you will. So we would have t over 2 times t over 2, which would be t squared over 4. T times t is t squared. 2 times 2 is 4. Times negative 7 is minus 7t over 2. Minus another 7t over 2. Those do not cancel each other out. And negative 7 times negative 7 is a positive 49. When I look at my answer choices, this one's out. A's got to be the correct one. Negative 7t, that's like negative 3.5t minus another negative 3.5t is a negative 7t. Because you have two of them. So the 2's go away. They cancel out and combine to be a negative 7t. That would be the correct answer.